In today's lesson, we'll be dealing with trigonometry, which is the study of relationships between the angles and the sides of triangles. The word trigonometry is derived from Greek. Hence, in trigonometry, to indicate angles, we use Greek letters. For example, theta, alpha, and beta, amongst many other letters that we shall be using to indicate angles. To understand trigonometry, we need to start with the right-angled triangle. What comes to mind when we speak of the right-angled triangle? Remember, in grade 8, you were introduced to the theorem of Pythagoras. Okay, I'm going to draw a right-angled triangle. This side, we have the right angle, which is a 90-degree angle. I will label it A, B, C. Now, let's label this right-angled triangle. Opposite the 90-degree angle or the right angle, we have the hypotenuse. The adjacent and the opposite sides are dependent on which angle is used as the reference point. For instance, if I were to call this part angle theta, it would mean that this side will be the opposite side because it's opposite to angle theta, and this side will be the adjacent side. Okay, but if I were to put beta here, it would mean this side will be the opposite side because it is opposite to beta, and then this side will be the adjacent side. The hypotenuse does not change. Anyway, let us to understand trigonometry. It is important that we revisit the theorem of Pythagoras. What comes to mind when we speak about the theorem of Pythagoras? What does the theorem of Pythagoras do? It basically describes the relationship between the three sides of a right-angled triangle. Okay, let me sketch another right-angled triangle. I will name this side in this context A, and then this side C, this side B. Okay, so opposite A, I will name this side small letter A, and then opposite B, I will name that side small letter B, and then opposite C, which is the hypotenuse, I will name it small letter C. So the theorem of Pythagoras states that C squared equals to A squared plus B squared. Some may choose to say AB squared equals to BC squared plus AC squared. Okay, after this, we may go to trig ratios or trigonometric ratios in full. But I'll shortcut it and write trig ratios. Remember, when we speak of a ratio, division one way or another is involved. In trigonometry, we've got three special ratios, which are sine, cosine, and tangent ratios. These are our three special ratios. When these are applied to a right angled triangle, they define the relationship between the sides and the angle. Okay? You can best summarize them as soccer tour. We're going to use the right angled triangle above. What does soccer tour mean? It means sine. In this context, I'll put theta here. It means sine theta equals to O, meaning opposite, over hypotenuse. And then from the right angled triangle above, the green one, what is our opposite side? Opposite to theta. It will be B in that context, and then the hypotenuse will be C. What about cosine? Cos theta in this context would be equals to adjacent over hypotenuse. What is our adjacent from the right angled triangle above? The adjacent side is A, and the opposites and the hypotenuse is C. Okay. And then let's go to tangent. Tan theta. Don't forget, cos is shortcut for cosine. Tan is shortcut for tangent. Tan theta equals to opposite over adjacent. It is the only one without a hypotenuse involved. So from the right angle triangle above, what is the opposite side? What is the opposite side? It's B, and the adjacent side is A.